All right, good morning, good afternoon, whenever you're starting here. We are continuing with volume, and what we did the last 2 days was what was called the disc method, where we pictured a bunch of frisbees stacked up on top of one another to create the volume of a solid. Instead of being frisbees or plate looking objects, we are going to be looking at washers. So if you've ever put anything together where you're putting a screw in and then you have to put a washer in on the back of it before you put on the final piece to keep something in place, whether it's a handle or whatnot, a washer just looks like kind of like a coin, but now you have the middle cut out. Okay, so what you're going to be picturing here is, if you look at this little black rectangle, and notice how it's not touching the x-axis. So when we rotate around the x-axis, you're actually going to have some space not being counted in our volume, okay? And that's where this hole comes in. So if you look at the blue figure over here, when you rotate it, you actually get an open space through the middle. And so when we're doing this is going to be very similar to the disc method, except we have to subtract the volume of the hole out as well, okay? So our formula here, if it's in the x direction, will look like this. Again, it's very similar to the volume of a solid using the disc method, except now we have a hole in the middle. So we saw during the last 2 days using the disc method, we reviewed that the volume of a cylinder is pi r squared times the height. And the height of those cylinders were the width, really. So when you're looking at this picture, it's the width of that rectangle. But that's also going to be our dx value. And then we just had our radius squared. So now it's going to be a little bit different, because looking here, we're going to call this capital R of x. So that's the radius if there was no hole, right? So that would be like the radius of the disc. We're still going to square that. But now we need to subtract out the inside piece, which I have in red, and that's going to have a smaller radius, and we're going to call that a lowercase r of x. Okay, and since we're in the x direction, that's why it's r of x instead of r of y. And we're just going to subtract those. And so that's the only thing that is different from what we did for days 3 and 4. We are going to be subtracting this smaller volume, and this is the volume of the hole. And that's what makes each little piece. So if you have this solid that has a hole in the middle, every little slice you make is going to be a washer compared to a disc, because they will all have holes in them. Okay? Okay, so example 1, I'm going to walk through with you, and then I will have you try one. Both of these will be about the x-axis. So the directions will read, find the volume of the solid generated by revolving the region bounded by the graphs of the equations about the x-axis. So you'll be given, in the problem I'm going to have you try by yourself, different graphs that's going to bound a region, and then we're still going to rotate about the x-axis. So all we have is y equals square root of x and y equals x squared. We know what both of those look like, but what we need to figure out is where they intersect. So you can do that one of 2 ways. If you have your calculator, you can graph them, see where they intersect, but you can also just set them equal to one another and solve. So to get rid of that radical, I'm going to square both sides, and I get x equals x to the 4th. If I set that equal to 0, I know that these two are going to intersect at x equals 0 and x equals 1. Okay, so when we look at our graph, I am going to draw it a little bit bigger. So we know they cross when x is 0. For both of them, that's 0, 0. And then when x equals 1, both outputs are at 1. So the square root of x is going to look like this. And y equals x squared is going to look like this. So it's important to know which is the top function of your rectangle. And we are going to rotate this still around our x-axis, okay? So it's this solid that we're rotating around. And so what you kind of want to picture here to get that 3D look and everywhere we slice this, no matter where, it's going to be a washer, okay? So what we have to figure out is what's the larger of the two radii of this outside. So if you're looking at this figure from the outside, what is the larger radius compared to what is the smaller? So when you look here, that's your r of x. And then from here to here, that's your hole that you're going to be cutting out in the middle, and that's your lowercase. Okay, so that's why it's important to know which function is on top. And here it is our square root of x. So when we go to set this up, our volume will equal pi from x equals 0 to x equals 1. Our larger function between 0 and 1 is the square root of x function. And we're going to square that minus the lower of the two functions is our x squared. And then this is in the direction of dx. Now, sometimes the focus is just on the setup, and if it's a calculator portion of the exam, then technically you could just plug this into your calculator by doing math 9 and getting a decimal value. If you don't include the pi when you do math 9 and you just do the integral from 0 to 1, it will give you 3/10, and then you know that's times pi. But we'll just walk through it quickly just so you can see the work for it. So the first thing we would do is square that, which would give us an x, square this, which would give us an x to the 4th, dx, and then we would integrate that using your power up rule. So that would become x squared over 2 minus x to the 5th over 5 from 0 to 1. And if we plug in 1, we get 1/2 minus 1/5, which equals 3/10 pi units cubed. Okay, so again, you could get that by doing math 9. If you don't have math 9, obviously, then you got to go through and do that work. So the next one I'm going to have you try, I am going to skip over to the next video just to keep these on the shorter side. It's going to be the same exact directions. So I'm just going to give you the equations that the region is being bounded by, and then it'll be rotated around the x-axis.